Okay, this is block 7 from topic 1. So you should be on page 25 in your textbook where block 7 starts. And on that page, you should see a picture. What is that a picture of? House. Is it an actual house?
No.
Stop. It's not an actual house. What is it of? I mean, a blueprint, a scale drawing of a house. Well, forgot where I was going with that. Oh, stop with the extra talking. How does blueprints, scale drawing, how does construction workers use what we've been talking about thus far with building houses? Raising your hand. Or is this the actual size of a house on your paper? What? They're using a scale factor. I agree. I see a scale factor is right here. That for this particular blueprint is using 1 centimeter is 2 feet. Is their actual house going to be measured in centimeters? No. Their actual house is going to be measured in feet. Okay? Anything else that construction workers use to build houses? They're using the measurements. They're having to use various types of ratios. We've been working with ratios to get to the larger product. Okay, so we're going to work with a couple questions. And this is number 1 and 2 in your book. Number 1 says they want you to find the dimensions of the actual living room. Well, right now the living room is 12.5 centimeters by 5.5 centimeters. Is that the actual size that it's going to be? No, you can't live in anything that is in centimeters. Or it would be a large amount. So that is what they're wanting you to do for number 1, is use your scale to find the actual dimensions. Number 2, they want you to find the area of the actual bathroom. How do you find area of a rectangle? Length times width. Okay? Well, is this the actual length and width of my bathroom? No, this is my scale drawing. So first I would have to find my actual length and width. Then I would be able to find my area. Okay, so I'm going to give you like a 3-minute timer. And you're going to work with your group to do problem 1 and problem 2 in your textbook. All right, you're set to go. Okay, let's go through. Number 1, we had to find the dimensions of the actual living room. So raise your hand if you feel like you found the dimensions of the actual living room correctly. All right, how did you find it?
So I multiplied 12.5 by 2, and I got 25.
Okay.
Then I multiplied 5.5 by 2, and I got 11.
So,
and the answer is 275 feet.
Are we finding area on the first one? No, we're not finding area. Is this centimeters, 25 centimeters, and 11 centimeters?
No.
What is this? Feet. So it said to find just the dimensions. So the dimensions, we got that. And where did this number 2 come from? Where did you get the number 2 from? the scale, so what was our scale factor? Here, 2. Okay, so we used our scale factor, multiplied by 2, and got my dimensions. Okay, raise your hand if you feel like you did number 2 beautifully and would like to explain. Yes, ma'am. What you got? 30. How did you get there? 2.5 times 2. What did you get when you did 2.5 times 2? 5 what? Okay. And what did you get when you did 3.5 times 2? 7 feet. And why did you get a 35? Where did that come from? Because we were told to find the area. Area is length times width. 5 times 7 gives me 35. So what is the actual area of the bathroom? 35 feet. Oh!
Square feet.
Oh, good catch. Area has feet squared. All right. Flip the page to number 3. You're going to have to listen. Number 3. It says, how would the length of the blueprint need to change in order to make the new blueprint of the same building with a scale of 1/2 inch equals 2 feet? So I changed the scale to 1/2 inch equals 2 feet. The question asks, I want to create the same building. So I have a blueprint. Can I have 2 different blueprint sizes but create the same size building? Yes. Okay, so I'm creating a new blueprint, but now my scale is 1/2 inch equals 2 feet. The question asks, how are these dimensions going to have to change if we created a new scale? What do you have? Okay. What do you think? Right. So, if I just went through and changed all the centimeters to inches, this would still create the same size building with that scale? No. Why not? You were on to something. What you got? No, there's an easier way of doing that. I had a definite no over here, like you were on to something.
So you can multiply each number by 2, and you can change the letters.
Okay, listen to what I'm saying. This was an old drawing. This drawing was for 1 centimeter equals 2 feet. These dimensions are no longer plausible to us because these are in centimeters. What's different from this scale to the new scale? What's the differences you see? Change centimeters to inches. What is the other difference? So it went from 1 to 1/2. Stop looking at everybody else. I want to pay attention. Me. Okay. 1 to 1/2. My scale went from 1 to 1/2. I want the same size building. 12.5 centimeters. was when it was 1 centimeter. Now it's going to a half. What do I have to do to all these numbers to create the same size building? You have to take half of all the dimensions, then it's going to create the same size building. Because our scale went down a half. So on number 3, you could say you would multiply all the dimensions by 1/2. Multiply all the dimensions by 1/2. Okay, I'm looking at your problem 4, and it is a picture of a map. And it is a map in California. And back before we had GPS, this is how we had to find distance on a map. We had to use scale factor. We had to use ratios. And we had to actually sit and calculate distance between points. Now we have what that's handy? Yeah. Our GPS on our phones or everything. It gives us pretty much to the exact foot of where something is. But we didn't have that back in the day. So, looking at my diagram right now, it has a scale. What is my scale? What does it say it is?
1
inch equals 5 miles. So it looks like I'm traveling from Los Gatos to where? Hayward? Okay. What happens when I zoom in? What's changing? Why would the scale change when I zoom in? Is the distance between the two cities changing? No. Why is the scale changing? I'm getting closer. When I zoom in more, now 1 inch represents 1 mile. Okay? Did the distance change when I zoomed in? No. Okay? Well, again, back in the day, this is how we had to measure the distance. Why am I not measuring straight to that red point? Is there a road going straight through that body of water? No, I'm having to take a certain road to get there. So I have to measure that road. So let's watch and see how we used to have to do it back in the old day. We actually had to measure out. So the scale said it was 5 miles for that inch. So we would sit there, figure out how many inches was in that trip. So if I found, how many inches did I find was in that trip? 8 inches. So how many miles is in that trip? 40. Does it look like I'm exact when I measured that? No. That curvy road, we're just estimating here because it's hard to get exact. So you can take some time, fill in your table. So did I travel 8 inches? No. On the map I traveled 8 inches, but I really traveled 40 miles. Well, there was another method we could use. I normally used this one back when I first started how to drive and there wasn't GPS. But some people would take a string, because can a string get all bendy? Yes. They would trace the or kind of lay the string on the route and then cut the string, the length of the route. Then what do you think they did with that string? They straightened it up and they measured it. That would give them a little more precise distance. In this case, it's not too precise, but we'll go with it. So, they're laying their string, they snip it, they take it and they pull their string straight to measure it. They say it's 8 inches, okay, probably would have been different. What are they doing there? Why did they multiply by 5? That's our scale factor. So they ended up getting the same distance. That's not always going to give you the same distance because we obviously did some good measurement there at the beginning. Alright, so I want you to look at the next page and I want you to circle problem 5C and 6. 5C and 6. These are two problems that you wrote on in your agenda. And what does it say about 5C and 6? They're due Friday and they're for a grade. So I'm going to explain how these are to be done. So 5C says you're going to make a scale drawing of one room in your house, apartment, or other location. Is Miss Adams going to drive to all those locations and make sure your scale drawing is correct? No. No, I don't have that much time. And I don't want to go to all of your houses. Okay? So, you're going to draw a bedroom. I will show you an example of one that I drew. So I sketched the outline of my bedroom. Here is my bed. I have a nightstand and a dresser. You need to write under 5C. 1 unit equals 1/2 foot. Half a foot. That is the scale I want you to use. 1 unit equals 1/2 foot. So looking back at my diagram, you have to have at least 3 objects in your room. So I have 3 objects. And I drew this yesterday during 8th hour. So did I go to my room and measure everything out? No, I just drew something. Well, here it's saying this whole side is 32 units, and then I have 16 feet underneath it. How did I get that? Why did I divide by 2? Because that's what my scale factor is. My scale factor is multiplying by 1/2. One of these squares represents 1/2 of a foot. So I counted 32. So I multiplied 32 times 1/2 and got that it was 16 feet. Then I did my bed. It was 12 units. That was 6 feet. I will have secret ways of knowing if you did this correctly or not, because if you have a bed that is 27 feet long, do you think you did a very good job on your scale drawing? I don't know of any bed that is 27 feet long. I don't even know of many bedrooms that's 27 feet long. Okay, so notice how all the items have the original units and then their scale measurement next to it. This is not a very good scale drawing of my actual room because it is not this large. 16 feet long is actually a pretty big bedroom. I don't have this much empty space in the middle. But, like I said, it's a good enough scale drawing. Any questions about how 5C goes? You just draw any one, and I need 3 objects. Okay. Now number 6. 6 is creating a blueprint of your home or a home of someone you know. Am I going to go to anybody's home and check this?
No.
No. For our home, we're going to use the scale 1 unit equals 2 feet. So number 6, you're writing 1 unit equals 2 feet. That's the scale we're going to use. Okay, so looking at the example of my number 6, I wrote, this is my number 6, my house, 1 unit equals 2 feet. And I see that it is 20 units wide, which means it's 40 units wide. 40 feet wide. How did I get that? I used my scale factor. Then I measured all my bedrooms. Is this exactly like my house? No, but it's probably similar. One thing I want you to keep in mind when doing your house. Most houses have a square footage of between 1,000 to 3,000. And 3,000 square foot is probably the square foot of the biggest house in Moss Bluff. Okay? So, my square footage needs to fall between this. How do you find square footage? Length times width. My length was 52. My width was 40. 52 times 40 gave me 1,080 square feet. Am I falling between the average size house? Yes. I'm pretty sure all of you live in Moss Bluff, and there is no mansion that is bigger than 3,000 square feet that I have seen in Moss Bluff. So you need to try and keep your square footage between 1,000 and 3,000. Your paper probably can't even fit more than 3,000 anyhow, if my scale is 2 feet. Okay. Any question on your house scale drawing? Yeah. So, all right, so you have 2 different graph papers. You have the rest of the class period to work on your scale drawings. It's due Friday. Your guided practice 1 through 6 is due Friday. You have some more practice 1 through 5 due Wednesday. And you have more practice 6 through 10 due Friday. Look at all those dates I have in my head. And that's just for y'all's class. Thanks, guys. Thanks for listening. Catch you later.